The CAN bus uses non-return to zero with bit stuffing. There are two different signaling states: dominant, logically 0, and recessive, logically 1. These correspond to certain electrical levels which depend on the physical layer used. There are several. The modules are connected to the bus in a wired AND fashion. If just one node is driving the bus to the dominant state, then the whole bus is in that state regardless of the number of nodes transmitting a recessive state. Different physical layers. A physical layer defines the electrical levels and signaling scheme on the bus, the cable impedance, and similar things. There are several different physical layers. The most common type is the one defined by the CAN standard, part ISO 11898-2, and it's a two-wired balanced signaling scheme. It is also sometimes known as high-speed CAN. Another part of the same ISO standard, ISO 11898-3, defines another two-wired balanced signaling scheme for lower bus speeds. It is fault-tolerant, so the signaling can continue even if one bus wire is cut or shorted to ground, or VBAT. It is sometimes known as low-speed CAN. SAE J2411 defines a single wire, plus ground of course, physical layer. It's used chiefly in cars, for example GM LAN. Several proprietary physical layers do exist. Modifications of RS-485 were used in the old ages when CAN drivers didn't exist. You can go to section 5 to view a number of oscilloscope pictures for those interested in the details of a message. Different physical layers cannot, as a rule, interoperate. Some combinations may work, or seem to work, under good conditions. For example, using both high-speed and low-speed transceivers on the same bus can work sometimes. A great many CAN transceiver chips are manufactured by Philips. Alternative vendors include Bosch, Infineon, Silicon-X, and others. A very common type is the 82C250 transceiver, which implements the physical layer defined by ISO 11898. The 82C251 is an improved version. A common transceiver for low-speed CAN is TJA 1054 from Philips. Maximum bus speed. The maximum speed of a CAN bus, according to the standard, is 1 megabit per second. Some CAN controllers will nevertheless handle higher speeds than 1 megabit per second and may be considered for special applications. Low-speed CAN, ISO 11898-3, can go up to 125 kilobits per second. Single-wire CAN can go up to around 50 kilobits per second in its standard mode, and, using a special high-speed mode used, for example, in ECU programming, go up to around 100 kilobits per second. Minimum bus speed. Be aware that some bus transceivers will not allow you to go below a certain bit rate. For example, using 82C250 or 82C251, you can go down to 10 kilobits a second without problems. But if you use the TJA 1050 instead, you can't go below around 50 kilobits per second. So make sure to check the datasheet. Maximum cable length. At a speed of 1 megabit per second, a maximum cable length of about 40 meters or 130 feet can be used. This is because the arbitration scheme requires that the wave front of the signal can propagate to the most remote node and back again before the bit is sampled. In other words, the cable length is restricted by the speed of light. A proposal to increase the speed of light has been considered but was turned down because of its intergalactic consequences. Other maximum cable lengths are, and these values are approximate, 100 meters or 330 feet at 500 kilobits per second, 200 meters or 650 feet at 250 kilobits per second, 500 meters or 1600 feet at 125 kilobits per second, 6 kilometers or 20,000 feet at 10 kilobits per second. If optocouplers are used to provide galvanic isolation, the maximum bus length is decreased accordingly. Hint: use fast optocouplers and look at the delay through the device, not at the specified maximum bit rate. Bus termination. An ISO 11898 CAN bus must be terminated. This is done using a resistor of 120 ohms on each end of the bus. The termination serves two purposes. 1. Remove the signal reflections at the end of the bus. 2. Ensure the bus gets correct DC levels. An ISO 11898 CAN bus must always be terminated regardless of its speed. I'll repeat this. An ISO 11898 CAN bus must always be terminated regardless of its speed. For laboratory work, just one terminator might be enough. If your CAN bus works even though you haven't put any terminators on it, you're just lucky. Note that other physical layers, such as low-speed CAN, single-wire CAN, and others, may or may not require termination, but your vanilla high-speed ISO 11898 CAN bus will always require at least one terminator. The cable. ISO 11898 prescribes that the cable impedance be nominally 120 ohms, but an impedance in the interval of 108 to 132 ohms is permitted. There are not many cables in the market today that fulfill this requirement. There's a good chance that the allowed impedance interval will be broadened in the future. ISO 11898 is defined for a twisted pair cable, shielded or unshielded. Work is in progress on the single-wired standard SAE J2411. CAN connectors. There is no standard at all for CAN bus connectors. Usually, each higher layer protocol defines one or a few preferred connector types. Common types include 9-pin D-sub, proposed by the Canon Automation or CIA group, 5-pin Mini-C and or Micro-C, used by DeviceNet and SDS, the 6-pin Deutsch connector, proposed by CanHug for mobile hydraulics.